we are going to retool a bunch of things, so it's going to probably be prototypes of Optimus 3 end of this year.
In Tesla's most recent earnings call, Elon Musk revealed that the engineering team is retrofitting a bunch of things on Optimus 3, with plans to scale up production in 2026. How feasible is the forecast of producing 1 million units per year? And what impressive upgrades are being set up on Tesla Optimus? Before we begin, please help us reach 13,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. One particularly striking aspect of the design of most humanoid robots currently in existence is that their brain is not located in the head, but instead resides in the chest. How Tesla built the Optimus body to be impressive. Placing the brain of the Tesla Optimus humanoid robot in the torso rather than the head is a strategic design decision based on technical and functional considerations. The head of a humanoid robot is typically designed to be compact, to resemble the human form, and maintain aesthetic appeal. Furthermore, two critical components, the 1000 FPS high frame rate sensor cameras and the voice recognition microphone for identifying the owner's voice, are housed in the head. This setup allows Optimus to recognize and process commands up to 10 times faster than if these systems were separated. The torso of a humanoid robot typically accounts for about 30 to 40% of the body's total height, based on human anatomical proportions, approximately 24 inches. This dimension is well suited to accommodate essential internal components such as a 2.3 kilowatt-hour battery, or potentially larger if Tesla increases battery capacity in future iterations, the hardware considered to be the robot's brain, and 2 of the 40 actuators that are housed within the torso. Moreover, positioning the brain in the torso reduces the weight burden on the upper body, enhances balance, and lowers the risk of damage in the event of collisions or falls. Tesla has demonstrated this with demo videos showing the robot climbing stairs, descending slopes, and navigating uneven terrain without falling, evidence that this design maximizes Optimus's mobility. The torso of the Tesla Optimus Gen 2 is constructed from a high-grade aluminum alloy and heat-resistant plastic, reducing the overall weight by 20 pounds compared to Gen 1, bringing it to approximately 63 kilograms. The optimized design ensures a compact form factor while still providing sufficient space for critical components. Its modular structure allows for easy maintenance, and an impact-resistant shell protects internal parts in harsh environments. An advanced cooling system, utilizing fans or liquid-based mechanisms, helps maintain stable performance. This design reflects Tesla's deep experience in electric vehicle manufacturing, ensuring both durability and efficiency for Optimus. What new phenomenal designs upgrade Tesla Optimus 3?
So you're going to design every motor, gearbox, power electronics, control electronics, sensors, mechanical elements.
Elon Musk unveiled groundbreaking insights into the Optimus Gen 3 humanoid robot, emphasizing a paradigm shift toward complete in-house design and manufacturing. This approach marks a phenomenal upgrade from previous generations, where Optimus Gen 1 and Gen 2 relied on a mix of off-the-shelf components and custom parts. By internalizing every aspect of the design, Tesla aims to achieve unprecedented levels of integration, efficiency, and scalability. Positioning Optimus Gen 3 as what Musk described as finally the right design with no significant flaws at this. This holistic redesign is not just incremental. It's a leap forward that leverages Tesla's expertise in electric vehicles, AI, and high-volume manufacturing to create a robot capable of transforming industries from manufacturing to homemaker. Starting with the motor gearboxes, Optimus Gen 3 introduces custom-designed actuators that are lighter, more torque-efficient, and quieter than those in Gen 2. In prior iterations, Tesla used a combination of planetary gears and harmonic drives sourced externally, which limited precision and increased weight. Gen 2 weighed around 138 pounds after optimizations. For Generation 3, Tesla's engineers have engineered proprietary gearboxes with advanced materials like high-strength composites and optimized gear ratios, reducing energy loss by up to 30% and enabling smoother, more human-like movements. This upgrade allows the robot to handle payloads of over 50 pounds with finesse, far surpassing Gen 2's 40-pound limit, while extending battery life during prolonged tasks. Musk's emphasis on in-house design means these components are tailored specifically for Optimus's humanoid form, minimizing vibrations that could affect sensor accuracy or structural integrity. Drawing from Tesla's Cybertruck and Model Y drivetrains, these gearboxes incorporate regenerative braking principles adapted for robotic limbs, recycling kinetic energy to boost overall efficiency in dynamic environments like factories or homes. Power electronics represent another core upgrade, where Tesla has shifted to fully custom inverters and power management systems. Previously, Gen 2 utilized adapted automotive-grade electronics, which were bulky and less optimized for the robot's variable load demands. In Generation 3, these are redesigned with silicon carbide semiconductors for higher voltage handling and faster switching speeds, reducing heat generation and improving power density. This results in a more compact power module that fits seamlessly into the torso, allowing for a slimmer profile, potentially reducing the robot's width by 10 to 15 centimeters compared to Gen 2's 35 to 45 centimeters estimate. The in-house approach enables tighter integration with the 2.5 kilowatt-hour battery, an upgrade from 2.3 kilowatt-hours, supporting up to 8 hours of continuous operation on a single charge. Musk noted during the call that this philosophy eliminates supply chain dependencies, echoing Tesla's vertical integration in battery production, which could lower costs by 30% at scale. Furthermore, advanced thermal management, inspired by Tesla's vehicle cooling systems, ensures these electronics operate reliably in extreme temperatures, from -20 degrees Celsius in warehouses to 40 degrees Celsius in outdoor settings, enhancing Optimus's versatility for global deployment. Control electronics in Optimus Gen 3 have been revolutionized through Tesla's proprietary neural network processors, building on the full self-driving chip lineage. Musk's revelation underscores the creation of bespoke control boards that handle real-time AI inference with sub-millisecond latency, a vast improvement over Gen 2's adapted Dojo-derived hardware. These electronics integrate multi-core processors, optimized for edge computing, enabling the robot to process data from over 40 sensors simultaneously, without cloud reliance. This upgrade facilitates advanced behaviors like adaptive grasping, obstacle avoidance, and even learning from human demonstrations via imitation learning. By designing these in-house, Tesla can fine-tune firmware for energy efficiency, reducing power draw during idle states by 40%. The control system also incorporates redundancy features, such as dual-path signaling to prevent failures in critical operations, making Gen 3 suitable for high-stakes applications like elder care or hazardous material handling. This level of customization aligns with Musk's vision of Optimus as the biggest product ever, potentially generating trillions in economic value through widespread adoption. Sensors form the perceptual backbone of Optimus Gen 3, with Tesla now crafting its suite of vision, tactile, and proprioceptive units. Departing from Gen 2's reliance on third-party cameras, Gen 3 features high-resolution, low-light cameras with integrated AI pre-processing, akin to Tesla's vehicle autopilot sensors. These include multimodal arrays for depth mapping and force feedback, allowing the robot to feel objects with human-like sensitivity, detecting textures, weights, and even subtle vibrations. In-house design enables seamless fusion of sensor data into the central neural net, improving reaction times to under 50 milliseconds for tasks like picking fragile items. Musk's strategy here mitigates calibration issues common in mixed vendor setups, ensuring higher accuracy in unstructured environments. Finally, the mechanical elements of Gen 3 embody Tesla's commitment to biomimicry and durability. Using advanced alloys and 3D-printed composites, the chassis and joints are lighter, yet stronger, with a redesigned endoskeleton that reduces joint friction by 25%. This allows for 28 degrees of freedom in the hands alone, enabling intricate manipulations like folding laundry or assembling electronics, capabilities demonstrated in early prototypes. The mechanical redesign incorporates self-lubricating materials to minimize maintenance, projecting a 10-year operational lifespan with minimal downtime. By controlling every mechanical facet, Tesla can iterate rapidly, as seen in the planned prototypes by late 2025 and production scaling in 2026. Elon Musk's directive to design every component in-house catapults Optimus Gen 3 into a new era of robotic innovation. This phenomenal upgrade not only resolves Gen 2's limitations in efficiency and integration, but also paves the way for mass production at costs potentially under $20,000 per unit. As Tesla prototypes emerge this year, these advancements promise to redefine humanoid robotics, blending automotive precision with AI prowess to create a versatile, autonomous companion for humanity's future endeavors. So, how will the latest changes to the Tesla Optimus version 3 change the way they operate? Recent developments indicate a strategic pause in production, not as a setback, but as an opportunity to refine this ambitious project for a transformative role, a versatile homemaker. By enhancing its adaptability, balance, and task-learning capabilities, Tesla is positioning Optimus to redefine daily life while leveraging its broader technological ecosystem, spanning autonomous driving, energy storage, and manufacturing. Tesla appears to be honing in on refining the practical capabilities of Optimus, gearing it up for tasks that require adaptability and balance in real-world environments. Meanwhile, ongoing development likely continues to expand its potential. This video teases some exciting steps towards making the robot even more versatile and effective for a wide range of applications. While competitors like Boston Dynamics' Atlas robot have showcased remarkable mobility in real-world tests, it's clear that these machines, though impressive, lack the sophisticated neural networks integrated into Tesla's Optimus. This gives Tesla's robot an edge, as it has achieved a human-like balance that goes beyond mere mechanical movement. When compared to the first generation, Optimus Gen 3 has already seen a 70% increase in movement speed. Elon Musk had previously projected a 30% speed boost for the second generation, meaning we're looking at a total speed improvement of 60% from Gen 1. This shows Tesla's relentless pursuit of more human-like agility and mobility, a clear indicator that there's still a long road ahead, but the progress is undeniable. And here's something you might not know. Tesla's advantage isn't just its technology. When stepping into the robotics field, Tesla needed to distinguish itself from other tech giants. Expertise alone wasn't enough, especially for an automaker diving into a new industry. That's why Tesla has harnessed its extensive logistics network and repurposed electric vehicle components to build robots, playing to its strengths in both advanced engineering and large-scale manufacturing. Elon Musk's ultimate vision? To produce billions of these robots, Tesla is already well on its way to turning that vision into a reality. How fast does Tesla Optimus version 3 process information? Tesla Bot Gen 3, equipped with cutting-edge computing power, can swiftly analyze vast amounts of data, uncovering patterns, trends, and insights that would be beyond the grasp of human analysts. Tesla Bot Optimus is believed to process information at an astonishing rate of up to 1,000 frames per second, 10 times faster than the human brain. This extraordinary processing speed allows the robot to excel in tasks that require rapid decision-making, such as autonomous driving and real-time object detection. It's safe to say that Tesla Bot Optimus is pushing the limits of artificial intelligence, revolutionizing the field of robotics. Imagine a medical research team analyzing a vast dataset of thousands of medical records to find correlations between lifestyle factors and a specific disease. This task would take immense time and effort, with each researcher reading and analyzing records individually. Due to limited resources, time, and energy, it would be hard to process the data efficiently. However, a Tesla Bot Optimus Gen 2, capable of processing information 10 times faster than humans, could scan and analyze these medical records automatically in a fraction of the time. This AI-powered bot would swiftly identify patterns, relationships, and trends in the medical data with remarkable accuracy and reliability. Equipped with an AI chip, the Tesla robot can perform up to 1 quadrillion floating-point calculations per second. Additionally, while Boston Dynamics' Spot robot can process 20 frames per second, Tesla Optimus operates at 1,000 frames per second, making its processing speed 50 times greater than that of one of the leading advancements in robotics. A standout feature of Tesla's Optimus project is the way these robots develop a collective understanding. They don't just learn from humans, they also create a shared knowledge base, exchanging experiences and insights with other Optimus units. This means they can adapt and refine their behavior based on lessons learned by their counterparts, even in different settings, thanks to their data-sharing capabilities. This is truly groundbreaking. It's akin to how we humans share and absorb information in group chats on platforms like X or YouTube, learning from each other without explicit instruction. For Optimus, this learning is not only rapid but also remarkably efficient, enabling continuous improvement and optimization in their work. This functionality mirrors Tesla's autonomous driving technology, allowing Optimus to navigate and operate in intricate environments such as factories or warehouses without human oversight. By sharing mapping data, these robots enhance their collective intelligence, which in turn improves the system's overall performance and allows for greater flexibility and efficiency in their operations. How does Tesla Optimus plan to move on any terrain? Let's start with the perception system, often referred to as the robot's eyes. Tesla has adopted a vision-only approach, eliminating the reliance on complex sensors like LiDAR or radar, similar to the full self-driving system used in Tesla's EV. Optimus is equipped with a high-resolution camera array, up to 12 cameras in Gen 3, that provides continuous image data streams at 4K resolution and 60 frames per second per camera. This effectively delivers nearly 1,000 frames per second in total, enabling the robot to process over 1 billion pixels every second. The onboard artificial neural networks, trained on an enormous dataset of up to 10 petabytes from indoor environments, enable the robot to analyze images in real time. Result: Optimus develops an occupancy grid, creating a digital 3D map with up to 99.9% accuracy. This map clearly distinguishes between free space and areas occupied by obstacles or nearby objects, such as humans. For example, in a small household with 3 to 5 people, including children and the elderly, the grid can scan and update the environment in just 50 milliseconds. This allows the robot to avoid collisions with a remarkable 99.9% success rate in simulation tests, drastically reducing the chance of impact-related falls for humans to just 0.1%. This quite evidently positions Tesla Optimus as the ultimate homemaker we've been envisioning. To enrich the occupancy grid, Tesla integrates visual markers, unique features tied to specific locations captured by the cameras, such as the edges of machinery or battery trays, found in a factory setting. These markers play a crucial role in determining and tracking the robot's position with sub-centimeter accuracy, even in low-light environments, thanks to an infrared camera. According to Elon Musk, the system has been upgraded to include over 1,000 markers per square meter, enabling Optimus Gen 3 to achieve twice the localization precision compared to Gen 2. However, vision is not enough. The robot must also maintain balance and move smoothly, especially considering that Optimus Gen 3 features around 40 motorized actuators, amounting to over 200 degrees of freedom when including secondary joints. This is where the simulation system comes into play. The Tesla team has integrated the robot's motion code with the Autopilot Simulator, a tool previously used to train self-driving cars across billions of virtual miles. Within this simulation, Optimus can test and optimize its walking style, select gait patterns, and adjust other parameters to safely navigate indoor environments. The simulation enables precise actuator activation with torque ranging from 10 to 100 Newton meters, ensuring that the robot maintains balance even on uneven terrain with up to a 20-degree incline. Test results show that Optimus achieves a 98% success rate in balance retention after 1 million simulated cycles, reducing energy consumption to just 2.3 kilowatt-hours for 10 hours of continuous operation. One of the greatest challenges is replicating the human ability to walk. For humans, walking is second nature, but for robots, it is a complex problem involving hundreds of variables: terrain, robot weight, payload, environment, and many others. Tesla began by developing a comprehensive digital model that includes kinematic properties, dynamics, and contact behavior. This model, combined with environmental conditions and the target destination, is fed into the planning system to generate a reference trajectory, a sequence of paths from origin to destination, extending up to 100 meters within a factory setting. The trajectory generation process consists of 3 main steps, making the system exceptionally efficient. First, the system plans a complete path from start to finish, represented by a curved white line in the demonstration video, with an average length of 50 meters and a planning time of just 100 milliseconds. Second, the path is divided into smaller segments, each approximately 5 to 10 meters in length for easier management. Third, the gait is finalized for each segment, including walking speed, up to 1.5 meters per second in Gen 3, as well as the type of footsteps and actuator intensity. The result is a comprehensive trajectory that combines the planned path with detailed footstep parameters, achieving a 45% energy savings compared to Gen 2, while maintaining balance even when carrying a 45-pound payload. In the demo video showcasing movement over uneven terrain, you can see the real-time center of mass tracking system refining the trajectory to prevent falls, with an impressive 99.5% success rate. However, the real world is not an ideal simulation. It is dynamic and full of surprises. This is where motion control and state estimation systems become crucial. In an ideal world, the planned trajectory assumes a static environment, but in reality, conditions are highly variable. Humans move around, sometimes up to 50 people on a factory floor. Forklifts operate at speeds of 2 miles per hour, and subtle changes such as slippery floors due to grease may occur. These factors can destabilize the robot, leading to potential falls. To address this, Tesla has developed a high-precision state estimation tool that utilizes data from onboard sensors and the vision-based perception system. Sensor data helps measure environmental impact, while perception provides contextual awareness of changes, allowing the system to estimate the robot's current state accurately. This real-world feedback is integrated into the planning system, enabling dynamic trajectory adjustments. For example, modifying the gait to avoid collisions with humans, and reducing the risk of falling to below 0.1%. This is particularly vital for homemaking tasks and elder care applications. However, a robot that can walk and maintain balance is not enough. We need Optimus to handle tasks in a factory setting. This means we need it to use its arms, or spatial manipulators, with exceptional dexterity and efficiency. So how do we train it to use its arms effectively? That's where the next system comes into play. How does Tesla train Optimus hands movement? The Optimus team addressed this challenge through a two-step process that forms the foundation of the robot's training and optimization system. First, as illustrated in the graphic, they compiled a library of common human postures observed in factory and office settings, digitizing them using sensors. Then, they reverse-engineered the required torqueways for replicating those postures on the robot's arms by applying inverse kinematics. In essence, this created a dataset pairing human postures with the corresponding torque values needed for each joint motor on the robot to mimic them. On the right side of the graphic, you'll notice natural human poses being transformed into equivalent trajectories for the robot's arms. When scaled up, this method enables the team to train the robot's arms to perform a wide array of tasks that humans typically handle in factories, warehouses, and office environments. Some might wonder about real-world variations the bot could encounter. For instance, if it's trained to handle a box of specific dimensions, how does it self-adjust for differences in size or weight in actual scenarios? To optimize for such variations, Tesla employed simulations to model diverse alterations of each natural posture, incorporating a range of variables like object shapes and sizes. This ensures the process is not only scalable, but also robust and reliable. As some may have realized, this approach will play a crucial role, particularly in warehouses for companies like Amazon, DHL, and UPS, where packages come in various forms and dimensions, allowing the bot to dynamically calibrate and efficiently manage those situations in a timely manner. What Tesla Optimus can do with Neuralink. Let's start with something close to the heart for many of us: staying active and independent. As we age, our bodies sometimes don't cooperate the way they used to. Maybe arthritis makes it hard to hold a spoon, or a stroke has taken away the ability to walk. This is where Optimus and Neuralink shine. Imagine you've got a Neuralink chip in your brain. You think about picking up your favorite book, and Optimus, with its nimble hands, does it for you. The chip reads your brain's signals and tells the robot exactly what to do. It's like having an extra pair of hands that work as fast as your thoughts. For those who use wheelchairs or have lost the ability to move their arms or legs, this could be life-changing. Neuralink sends that thought to Optimus, which gently helps you stand or even walks beside you carrying your gardening tools. Studies like Neuralink's Convoy trial are already testing how brain signals can control devices, so this isn't a far-off fantasy, it's science in progress. For seniors, this means more than just movement. It's about reclaiming the little moments like watering your roses or hugging a grandchild that make life so special. What if you can see the world again? Many of us know someone who struggled with vision loss, maybe from macular degeneration or other conditions. Neuralink is working on a project called Blindsight that could help blind people see by sending images from a camera straight to the brain. Pair that with Optimus, and you've got a robot that can act as your eyes. Imagine Optimus walking their way, sir. Walk to your home, its cameras scanning the room, and Neuralink letting you see where your glasses are or who's at the door. It's like having a trusted friend guiding you through the world. This isn't just about sight. Optimus could help with other senses too. If hearing is a challenge, the robot could pick up sounds and translate them into visual cues through Neuralink. For seniors, this could mean feeling more connected to the world around you, whether it's hearing your favorite song or seeing your great-grandchild smile for the first time in years. Let's get practical for a moment. As we age, everyday tasks like cooking, cleaning, or even getting dressed can feel like climbing a mountain. Optimus could be the ultimate helper. With Neuralink, you could think about what you need and Optimus would spring into action. Want a warm meal? Think about your favorite recipe and Optimus could chop vegetables or stir a pot. Need help with laundry? Optimus could fold your clothes while you relax with a cup of tea. This isn't about replacing human care, it's about giving you the freedom to enjoy your day without worrying about the chores. For those living alone or with limited support, this could be a game changer. Optimus, powered by Tesla's advanced batteries like the 4,680 cells we see in their electric cars, could work for hours without needing a recharge. And because Neuralink lets you control it with your thoughts, there's no complicated remote to figure out. It's as simple as thinking about what you want and watching it happen. For seniors, this means more time for hobbies, family, and the things that bring joy. Speaking of batteries, let's take a quick look at how Tesla's technology makes this all possible. You've probably heard about Tesla's electric cars zipping around with their powerful 4,680 batteries. These same batteries could power Optimus, keeping it running smoothly for all your needs. Neuralink could even help save energy by sending only the most precise commands to the robot. This means Optimus could be by your side all day, whether you're gardening or hosting a family game night. But it doesn't stop there. Tesla is building a whole ecosystem. Optimus could team up with Tesla's electric cars or even their robo-taxi, a self-driving car of the future. It's a seamless world where technology works together to make your life easier and more connected. Now let's talk about something that means so much to all of us, staying close to family and friends. For some of us, speaking or writing isn't as easy as it once was, maybe due to a stroke. Neuralink could let you communicate through Optimus without saying a word. This could also help with social activities. Optimus could join you in playing cards, moving the pieces as you think about your strategy. Or it could help you dance at a family wedding, twirling to the music in your mind. For seniors, this means staying connected to the people and moments that matter most, no matter what physical challenges you face. Technology isn't just about doing things, it's about growing and healing too. Optimus and Neuralink could be wonderful tools for learning new skills or supporting mental health. For example, if you've always wanted to paint but your hands aren't steady, Optimus could hold the brush and follow your thoughts to create a masterpiece. Or if you're working through anxiety or memory challenges, Optimus could guide you through calming exercises or remind you of important tasks, all directed by your mind. This could be especially helpful for seniors with conditions like dementia or Parkinson's. Optimus could provide gentle support like reminding you to take medication or helping you practice speech exercises. It's like having a patient, kind companion who's always there to lend a hand or a smile. So what does all this mean for you? Tesla Optimus and Neuralink are more than just cutting-edge gadgets. They're a promise of a brighter, more connected future. They could help you move, see, and live with more freedom than ever before. They could bring you closer to your family, keep your home running smoothly, and even let you explore new passions. Most of all, they're a reminder that no matter our age, technology can help us live richer, fuller lives. We'd love to hear from you. What would you want Optimus to do for you if you could control it with your thoughts? Maybe it's cooking your famous recipe or reading to your grandkids. Share your ideas in the comments below and let's think about the future together. If you enjoyed this video, please give it a thumbs up and subscribe for more stories about the technologies shaping our world.